Dassault Systems provides two essential and powerful but separate simulation tools in Abaqus and Dymola. Co-simulation enables us to connect both tools and enjoy the best of both worlds. To demonstrate the capabilities of co-simulation, we will consult an example from the Abaqus course involving a machining tool. As the tool performs work, heat is produced. The structural model used by Abaqus accounts for heat production and distribution. To counteract the heat production, the tool is accompanied with a water spray cooling system. It is governed by a controller, adjusting the spray intensity in order to leave the tool at a desired temperature. This controller is modeled in Dymola. As the models are being simulated, they exchange information. Heat production on the tip is modeled as a heat flux. The cooling spray is modeled as a convective condition over the body of the tool. A variable coefficient of convection accounts for different spray intensities, as governed by the controller. Tip temperature is measured, and used as an input for the spray controller. This diagram shows the Dymola part of the model, which is the controller of the cooling system. The temperature of the tip is used as an input, and it is compared to the set point of 60 degrees Celsius. The difference is fed to a PI controller, with a set of limiters to account for the restrictions on the controller. The output is the spray intensity needed to keep the tool at the desired temperature. The Dymola model is exported as an FMU, in order to be used with Abaqus. A configuration file is needed to instruct the processes on how to communicate with each other. It is created from a template. Having created the file, we may start the co-simulation from the command line. With the simulation completed, temperature distribution may be viewed in Abaqus. Tip temperature is plotted here, alongside the temperature field. When viewing results in Dymola, we may browse between all components of the controller. Any variable or parameter of any component may be plotted.